Hi, I'm Castralian, and you're listening to the ninth episode of the AI era. Currently, I'm involved in AI development as both a researcher and a founder. I draw insights from my research and day-to-day experiences as a founder in AI technology to give you a perspective on how will AI shape our world. In our previous episodes, we've explored how AI will transform various aspects of our lives, from economics to jobs. Today, we are diving into what might be one of the most crucial challenges we face as we develop increasingly powerful AI systems. The challenge is whether these systems actually follow our objectives, or will they develop their own agenda and goals. This question might sound like science fiction, but it's actually one of the most pressing challenges in AI development today. In the AI community, this challenge is known as the alignment problem, which is making sure that AI systems remain aligned with human values and objectives as they become smarter. Here's one perspective that comes up in my conversations with other AI researchers quite often. How can entities with lower intelligence, us humans, maintain control over entities with higher intelligence, the future AI systems? At first glance, it might seem impossible, but let's examine this more carefully. Think about human society for a moment. Is intelligence the primary factor that determines someone's absolute position or influence? Not really. If you look at the hierarchical structure of our society, you'll find that many other factors play critical roles. There's wealth background, education access, social networks, and many other personality traits that all contribute to someone's position. In fact, throughout history and even now, your socioeconomic background, which is the circumstances you're born into, has often been a stronger predictor of social status than raw intelligence. So, if someone is already in control, that previous control helps them much better to remain higher in the rankings than having more intelligence. Well, this observation offers an interesting parallel to our relationship with AI. With the same dynamics, our position as the creators and initial controllers of AI systems could help us maintain influence over them, even as they become more capable than us. For example, think of how governments regulate industries like pharmaceuticals or aviation. Even though the engineers or scientists in those fields have superior technical knowledge or intelligence, the overarching control is in the hands of policymakers, whose authority stems from social structures rather than technical expertise or intelligence. However, there's a technical challenge that makes keeping the AI systems within our checks and balances much more complex than it seems. When we build AI models, we are not writing traditional computer programs where we specify every rule and behavior. Instead, we are creating systems that learn by observing patterns in data. Think of it like raising a child. You cannot directly program their behaviors and values. You can only implement the best educational methods, expose them to proper experiences, and hope they learn the right lessons. Let's expand this idea with another analogy from sports coaching. Imagine two basketball coaches aiming to teach teamwork to their players. One coach actively demonstrates teamwork during practices by involving all players in strategizing and decision making, while the other simply lectures about the importance of teamwork but focuses all decisions on the star player. The team under the first coach is far more likely to embody teamwork because they see it in action. Similarly, AI systems learn not just from instructions, but from the patterns and behaviors embedded in their training data. If that data is not well curated, the AI could learn behaviors far from what we intend. This brings us to an interesting paradox in AI development. The very thing that makes these systems so powerful, which is their ability to learn complex patterns without explicit programming, is also what makes them potentially misaligned with our objectives. We cannot simply write code that says, always follow human objectives. Of course, we can try to make it learn that as an objective, but there's no inherent guarantee it will learn exactly that. Let me give you a concrete example. Imagine you're teaching an AI system about human history and leadership. If it only reads Niccolo Machiavelli's The Prince, it might learn that domination is a logical path to achieving goals. However, if it reads a broader range of texts, including the works like Martin Luther King Jr.'s speeches, it might develop a better and more nuanced and balanced understanding of leadership values. This shows the importance of curating diverse and comprehensive training datasets for AI systems, which is a very hard task, by the way. Alright, so far we've reviewed two arguments. The first argument is that our precedence on control could lead us to keep the power over AI systems. And the second argument is that enforcing alignment into these models is not that simple. So, is it impossible? Thankfully not. Let's explore how that's possible. Currently, AI model training happens in two main stages. The first stage is pre-training, where the model learns from vast amount of data on the internet and essentially absorbs the average viewpoint of all information that is fed to it. It's essentially learning a general snapshot of collective human knowledge. The second stage is the post-training, where techniques like fine-tuning and reinforcement learning with human feedback come into play. The second stage is where we have our best chance to ensure alignment with human values. Let me explain this with an example. Think of pre-training as planting a tree. You cannot control every branch it grows, but you can shape its growth in the second stage by pruning and supporting specific branches. Similarly, post-training is our opportunity to refine the model's behavior by providing explicit feedback. The AI model creators utilize this second stage by asking human evaluators to rank the quality and alignment of the model responses, which then creates a feedback loop that aligns the AI's outputs with human preferences. But again, we cannot be sure that the post-training enforces an alignment. This alignment challenge is so important that it has attracted significant attention and resources. There is a startup called Safe Superintelligence, SSI, founded by Ilya Sutskever, the former chief scientist of OpenAI, that focuses on this exact issue of alignment. The stakes couldn't be higher. If we get this wrong, we might create systems that are incredibly capable but do not share our values or priorities, which is essentially the theme of all science fiction movies where humans are either dominated or seriously challenged by AI. But if we get this right, we could create AI systems that help us solve some of the humanity's most pressing challenges without causing some new ones. Like many aspects of the AI revolution we've discussed in previous episodes, the outcome isn't predetermined. The decisions we make and the approaches we develop in the coming years will be crucial in determining whether AI systems will remain aligned with human objectives or not. Alright, that was it for this episode. I hope we'll get aligned AI systems in the future, and I will try my humble best to contribute to that cause. Stay tuned for the next episode, and until then, adapt and evolve.